Hyperstealth's patented laser splitter technology has the potential to significantly advance self-driving vehicle and humanoid robot vision systems. The patent enables a single laser to be split into a few hundred smaller lasers and scaling up with additional material layers to 100,000 or even millions of smaller lasers, with demonstrations showing over 20 million splits from the original source. LiDAR, laser-based radar, can use a series of lasers and receivers which need to be spinning around 10 times a second to function. This is known as 360-degree spinning LiDAR, and the more lasers in series the better the resolution, but this leads to cost increases and still has a spinning mechanism that will be prone to breakdowns. Another LiDAR option can employ a single pulsing laser and a rotating mirror to allow it to scan the surrounding environment. This is known as a 2D rotating mirror LiDAR. However, these mirrors must spin around 160 times a second or faster, limiting the lifespan of the spinning mechanical components. The MEMS module is another form of LiDAR that uses a small micrometer scanning mirror that oscillates at 640 times a second, but this form of LiDAR doesn't have the range requirements for most self-driving vehicles and still has a mechanical component with the oscillating mirror and a limited field of view. A fourth option is a 1D rotating mirror, which uses a series of lasers that uses a single mirror that spins around 5 times a second, allowing for a wide field of view, but still requiring a mechanical component and numerous lasers. LiDAR ASIC, which stands for Application-Specific Integrated Circuits, is another option where hundreds of small lasers are placed onto a single optical chip, but these have a limited number of lasers in comparison to Hyperstealth's laser splitter. Hyperstealth estimates their splitter could theoretically achieve up to 2 trillion pulses per second, which is approximately 200,000 times faster than the fastest existing LiDAR systems. Increasing the number of laser points in a LiDAR-generated point cloud directly enhances resolution. However, splitting the laser decreases range. This can be compensated by employing more powerful lasers or adjusting the degree of splitting to achieve longer-distance scanning. Hyperstealth's laser splitter system does not need any moving parts or extra source lasers to achieve a wide field of view. Physical AI refers to artificial intelligence that interacts directly with the real world, such as self-driving vehicles, which frequently incorporate LiDAR sensors. Rivian announced in December 2025 plans to integrate LiDAR into its autonomous features, targeting deployment in their R2 models by the end of 2026. Their proprietary AI chip is expected to process up to 5 billion pixels per second. On February 9, 2026, Ouster, a LiDAR manufacturer, announced the acquisition of Stereolabs, a machine vision camera maker, for $35 million and 1.8 million shares. This merger aims to establish a leading platform for sensing and perception in physical AI, according to Ouster's CEO Angus Pakala, serving industries including robotics, automotive, and smart infrastructure. Eric Aguilar, formerly with Tesla, co-founded Omnitron Sensors in 2019. His bet: all robots, whether vehicular or humanoid, will need LiDAR to see. His company is aiming to enhance LiDAR reliability and affordability by leveraging semiconductor manufacturing processes. Aguilar notes frequent calibration and where issues in current LiDAR designs due to numerous moving parts are particularly problematic for automotive use. Original equipment manufacturers require longer-lasting sensors, as replacements every 2 to 3 months are not acceptable. The application of Hyperstealth's laser splitter in LiDAR allows for static, non-rotating designs, as the multiplicity of laser beams creates the necessary point cloud without a spinning mirror for forward-looking LiDAR. Physical AI platforms typically utilize advanced computing, cameras, and either LiDAR or radar as core sensing modalities, though radar lacks the precision necessary for fine detail recognition. Humanoid robots are increasingly popular, and their safe integration into daily life relies on sophisticated environmental perception beyond camera capabilities alone. For applications requiring only short-range LiDAR coverage, 10 meters or less, Hyperstealth's laser splitter system may be implemented without additional hardware or a significant reduction in point cloud density. A primary limitation of dramatically expanding point clouds is the computational power required to process the increased data. Advances in AI chips, such as Rivian's ability to process 5 billion pixels per second, are gradually mitigating these constraints. Hyperstealth technology offers flexibility, allowing adjustment of the point cloud density to match current processing capacities and scaling up as advances occur. If, as Aguilar suggests, all robots, vehicular or humanoid, will rely on LiDAR for visual input, Hyperstealth's innovation could deliver smaller, more affordable, durable LiDAR systems with superior resolution and safety outcomes. The surge in demand for humanoid robots, which require only short-range environmental scanning, makes integration of Hyperstealth's laser splitter with stationary LiDAR systems both practical and advantageous. Hyperstealth now has 48 patents granted or accepted in the field of physics, containing 847 claims, with 11 more patents approved but not yet granted, with a further 310 claims.